Hey everyone, ready for a deep dive into something truly out of this world? We're talking lunar construction today. And believe me, this is way more exciting than it sounds. You know all those sci-fi movies with people hanging out in moon bases? Well, turns out they might not be so sci-fi after all. You shared this article with us and it's fascinating. From astronaut blueprints to lunar blueprints, the future of moon construction. It got me thinking about how NASA's Artemis program is aiming to build a permanent moon base. And get this, they plan to use lunar soil like moon dust as their main building material. So the big question is, how on Earth, or I guess on the moon, do you build something using moon dust? The article starts with that iconic image of Buzz Aldrin's blueprint, you know the one, a human footprint on the desolate lunar surface. Powerful imagery, right? But it also got me thinking about what that boot actually sank into, which is way more complex than just dust. To help break down the science, we have our resident expert in material science and lunar geology. Welcome to the deep dive.
Thanks for having me. Glad to be here. That image of the boot print really does capture the essence of the challenge we're facing. Lunar soil, or regolith as it's technically called, is the foundation for any lunar construction. And it's definitely not like the soil we have here on Earth. It's been formed over millions of years by meteoroid impacts pulverizing the moon's surface.
So not exactly the stuff you'd find in your garden then. What are we really dealing with here?
Imagine walking on a beach made entirely of crushed glass. All those tiny glittering shards, that's closer to what lunar soil is like. All those particles are diverse, jagged, and way more challenging to work with than Earth's soil.
Okay, I'm starting to get the picture. And I can only imagine how expensive it would be to ship tons of building materials from Earth to the moon. Talk about astronomical shipping costs. But the article mentions that NASA is partnering with Icon Technology, Inc. to use the resources already on the moon. What's their plan?
Icon is a leader in 3D printing technology, and they're developing a system to melt lunar soil and shape it into a ceramic-like building material right there on the moon.
So basically a giant robotic potter using moon dust as clay. That's pretty awesome. But the article also points out that moon dust isn't exactly the friendliest building material. It's super abrasive, right? Wouldn't that cause problems for equipment and habitats?
Yeah, definitely. Every landing, every rover driving around kicks up this fine, sharp dust. It gets everywhere and can cause serious wear and tear on equipment, not to mention the potential health hazards for humans.
So it's like a constant sandblasting, but with microscopic moon shards. Not ideal for a long-term base. On top of the abrasive dust issue, the article mentions that the composition of lunar soil itself is a hurdle for 3D printing. Can you explain that a bit more? What's the issue there?
The composition of lunar soil isn't uniform. It can change drastically, even within a small area.
Because you never know what you're going to get. It's like a lunar grab bag. How does that impact the construction process?
Well, those variations can really impact the melting point and the strength and stability of the building material.
It's like trying to build a skyscraper, where the steel's strength changes on every floor. You need consistency, right?
Yeah. Exactly. And that's where the unpredictable nature of moon dust creates a real challenge.
This is where Northwestern University comes in, right?
Mm-hmm.
They're creating a library of lunar soil compositions using simulated moon dust. Are they basically building a recipe book for moon dust?
That's a great way to put it. They're meticulously analyzing these simulated soils, using techniques like microscopy to identify the mineral composition, potential water content, and any variations that could affect the melting point.
Wow, that's some serious detective work. But how does that help with actually building on the moon?
The goal is to give the 3D printer the ability to analyze each scoop of lunar soil it gathers and instantly compare it to this huge library of compositions.
So the printer would know exactly what kind of moon dust it's working with, kind of like a high-tech chef checking their ingredients.
Exactly. Based on the analysis, the printer can adjust its parameters, things like heating, cooling, and layering, to make sure the final product is strong and stable no matter what the exact makeup of that batch of moon dust is.
That's incredible. We've gone from boot prints to blueprints, and it all comes down to understanding and adapting to this unique moon dust. It's amazing to see how cutting-edge technology is making lunar construction a reality.
And what's really fascinating is that this technology isn't limited to the moon. The research and development happening now could revolutionize construction here on Earth, too.
Whoa, hold on. We're talking about building on the moon, and now we're back on Earth? I'm intrigued. How does that connection work?
Well, imagine applying these techniques to building in extreme environments here on Earth. Deserts, disaster zones, even underwater. Places where traditional building materials are scarce or transporting them is a logistical nightmare.
Okay, I'm starting to see the possibilities. We could potentially use this technology to create sustainable, resilient structures, using local materials even in the most challenging environments.
Exactly.
Wow. This lunar construction project is more than just building a moon base. It's a launch pad for innovation on multiple fronts. But before we get too earthbound, let's get back to those lunar blueprints. The article mentions landing pads as a major priority. Why are those such a big deal?
Remember that abrasive lunar dust we talked about? Every time a spacecraft lands, it creates this massive dust cloud. It's not only a risk to the landing craft itself, which needs clear visibility for a safe touchdown, but it can also damage any surrounding structures and equipment.
So it's not just about having a smooth spot to land. It's about protecting the entire lunar base from a dust storm every time a ship comes in. How do they plan to address that?
They're exploring using that same 3D printing technology to create these really durable landing pads. By melting and fusing the lunar soil into a solid surface, they can minimize dust dispersal and create a stable landing zone.
That's brilliant. It's like tackling two challenges with one solution. You're using the same technology and materials to both build the base and protect it from dust damage.
It really speaks to the ingenuity of the engineers and scientists involved, and it highlights a crucial aspect of space exploration adaptability. We can't just impose our Earth-based construction methods on the lunar environment. We have to work within its constraints and leverage its unique resources.
That adaptability reminds me of something else I read in the article, Multipurpose ISRU. Can you decode that acronym for me and everyone listening?
Of course, ISRU stands for In Situ Resource Utilization. In simply terms, it means using the resources you find at your destination rather than hauling everything from Earth.
So lunar homesteading, I love it. What makes it multi-purpose?
In this context, it refers to using lunar soil for a whole variety of applications, building structures, creating landing pads, and potentially even extracting valuable resources like oxygen and water.
So they're trying to create a self-sustaining ecosystem on the moon. That's super ambitious. But we've talked about how lunar soil can vary so much from place to place. Wouldn't that affect their ability to, say, extract resources consistently?
You've hit on a crucial point. Lunar soil isn't homogeneous. Its composition can change dramatically depending on the location. Some areas might be richer in certain minerals that are ideal for building, while others might have higher concentrations of volatiles, things like water ice, trapped within the soil.
And these differences matter because
They can significantly affect the efficiency and viability of resource extraction. It's like trying to mine for gold, but the size and purity of the nuggets change with every shovelful of earth. You need to be able to adapt your techniques to ensure consistent results.
So even with all this incredible technology, they're still at the mercy of the moon's unpredictability. It really makes you appreciate how complex this whole endeavor is.
It's a constant dance between pushing technological boundaries and respecting the limits imposed by the lunar environment.
It's amazing to think that we're on the verge of actually building structures on the moon using nothing but moon dust.
But beyond the technical marvels, I'm curious about the bigger picture. What does this tell us about the future of space exploration? It signifies a huge shift from simply visiting other worlds to actually inhabiting them. We're moving beyond leaving footprints to creating lasting infrastructure, which opens up incredible possibilities for the future.
It feels like we're on the edge of a new era, a time when humans might truly become a multiplanetary species.
It's definitely a giant leap in that direction, and the lessons we learn from building on the moon will undoubtedly inform our approach to exploring and potentially settling other celestial bodies. Imagine adapting these techniques for Mars, for example, using Martian regolith to create habitats.
That's mind-blowing. We've covered so much ground already, from the intricacies of lunar soil to the broader implications for space exploration. But before we wrap up this first part of our deep dive, I want to go back to something you mentioned earlier about the potential applications of this technology here on Earth. Can you elaborate on that a bit more?
Absolutely. Imagine a world where we can create sustainable and incredibly resilient structures, using only locally sourced materials, even in the most challenging environments.
So we're talking about more than just building houses. We're talking about revolutionizing disaster relief, creating infrastructure in remote areas, maybe even tackling the housing crisis in densely populated cities.
You're getting the picture. The possibilities are vast and the potential benefits are enormous. By adapting the techniques developed for lunar construction, we can create solutions for some of the most pressing problems facing humanity right here on Earth.
That's an incredibly inspiring thought. It seems like this whole endeavor is a win-win, pushing the boundaries of space exploration while simultaneously creating solutions for a more sustainable future here at home.
It really underscores the interconnectedness of scientific discovery. Often, the pursuit of knowledge in one field leads to unexpected breakthroughs in others. And this is a perfect example.
That's a great point. So, to all our listeners out there, keep those questions coming. We'll be back soon with part 2 of our deep dive, where we'll explore even more about the future of lunar construction. And who knows, maybe even touch down on Mars.
Welcome back to the deep dive. When we left off, we were talking about how the technology being developed for lunar construction could have some really groundbreaking applications back here on Earth.
Yeah, it's mind-blowing to think that the quest to build a moon base could actually help us solve problems here at home.
It really shows you how connected science and innovation are. Sometimes the biggest breakthroughs come from exploring fields that seem totally unrelated.
Like a cosmic ripple effect. Speaking of connections, the article also talks about something called multi-purpose ISRU. It sounds kind of Star Trek-y. Can you remind our listeners what that stands for again?
Sure. ISRU stands for In Situ Resource Utilization. It basically means living off the land but on the moon. It's all about using the resources that are already there instead of shipping everything from Earth.
Lunar sustainability. I like it. What makes it multi-purpose, though?
Well, it means that scientists are looking at using lunar resources for a ton of different things, not just for construction. Think extracting oxygen and water from the soil, or even creating rocket fuel from lunar elements.
Wow, a whole lunar industry.
Correct.
But we've talked about how much the composition of lunar soil can vary. Wouldn't that make it tough to extract those resources consistently?
That's a great point, and it's definitely a challenge that researchers are working on. Imagine you're panning for gold, but the amount of gold you find changes with every panful of dirt. You'd have to be constantly adjusting your technique. It's similar with lunar resources.
So even with the best technology, we're still limited by the moon's unpredictability.
Exactly. It's a constant dance of adaptation and innovation. Which brings us back to that library of lunar soil simulants that Northwestern University is developing. By having a detailed understanding of all the different compositions of moon dust, they can develop techniques for extracting resources that will work no matter what the specific makeup of the soil is.
It's like giving lunar prospectors a high-tech treasure map, helping them find the most valuable resources. Okay, let's switch gears a bit and talk about the human element. The article mentions the challenges of actually sending people to build and live on the moon.
That's where things get really complex and the stakes are super high. We're talking about long-duration missions, exposure to radiation, the psychological effects of isolation and confinement, and the need for a life support system that can work reliably in a really harsh environment.
It sounds like the ultimate test of human ingenuity and resilience. What are some of the main things to consider when designing a habitat for people to live on the moon?
One of the biggest concerns is protection from radiation. Unlike Earth, the moon has almost no atmosphere and no global magnetic field, so it's constantly being hit by harmful radiation from the sun and from cosmic rays. Lunar habitats need to have really strong radiation shielding to keep people safe.
Like a high-tech bunker, but for cosmic bullets. What about the psychological effects of living in such an isolated and confined space? I imagine that could be really tough on astronauts.
You're absolutely right. The psychological well-being of lunar inhabitants is crucial. Imagine living in a small enclosed space millions of miles from home, with limited social interaction and knowing that help is a long way away if something goes wrong.
That's a lot to deal with. What are researchers doing to address those psychological challenges?
They're looking at a lot of different things. Designing habitats with space for privacy and recreation, developing virtual reality systems that can simulate natural environments, and help people feel connected to Earth.
Like creating a little piece of Earth on the moon?
Yeah.
What about the everyday things like food and water?
That's where ISRU comes in again. The goal is to develop systems that can extract water from lunar ice deposits and grow food in controlled environments so we're not completely reliant on supplies from Earth.
Like a hydroponic garden on the moon?
Oh,
I love it. It sounds like more than just a sterile outpost, like a real community.
that's the vision.
It's all incredibly inspiring, but it also makes me think about the ethical side of things. Who gets to decide what happens on the moon? Who owns the resources?
These are really important questions, and they're being discussed a lot as we plan for the future of space exploration. As we start to explore and potentially settle on other planets, we need to have clear international guidelines and regulations. to make sure that things are done responsibly and fairly.
So like a whole new set of laws for a whole new world. What about the environmental impact of lunar construction?
Yeah.
How do we make sure we're not harming the lunar environment while we build our bases and extract resources?
That's another crucial thing to consider. The moon has a very fragile ecosystem, and even small changes can have big effects. We have to prioritize sustainable practices, minimize waste, and develop technologies that work with the lunar environment, not against it.
Like learning to be good neighbors in space.
Exactly. And this idea goes beyond the moon. As we explore further into space, we need to have a mindset of responsible stewardship, making sure that what we do today doesn't prevent exploration and discovery in the future.
That's a powerful message. It reminds us that our choices have consequences not just for us, but for future generations and for the places we explore.
And it's a message that applies to our lives here on Earth, too. As we face challenges like climate change and resource scarcity, we need to think about how our actions will affect the future.
It's a call to action for sure. Well, we've covered a lot in this second part of our deep dive, from the technical aspects of building on the moon to the ethical and societal implications of having people live there permanently. Stay tuned for part 3, where we'll explore the future of lunar construction even more and talk about how it could impact our lives here on Earth. Welcome back to the deep dive. In the last 2 parts, we went from the nitty-gritty of moon dust to the grand vision of a self-sustaining lunar base.
We covered a lot of ground exploring the amazing tech that's making lunar construction possible, and also the tricky ethical and social questions that come with having humans living on the moon.
Yeah, it's been a wild ride. And in this final part of our lunar deep dive, I want to keep exploring.
We've talked about using lunar resources to build all kinds of things, habitats, landing pads, oxygen, you name it. But I'm really curious about how all this could affect us back here on Earth.
That's a great point. It's easy to get caught up in the excitement of building on the moon. But we should definitely think about the bigger picture. What kind of economic and technological benefits could we see from all this?
Well, the advancements in 3D printing and robotics that are being developed for lunar construction will probably have a huge impact on a bunch of industries here on Earth. Imagine using that same tech to build affordable housing, or create infrastructure in disaster zones, or even build underwater habitats for research.
It's like what we learn on the moon could come back and change how we live and build here. What about the economic impact? Could a lunar economy actually create new jobs back home?
Absolutely. Think about all the companies that are building the tech for lunar construction and the businesses that will be involved in supporting those lunar settlements. Plus, all the new industries that will pop up as we start using lunar resources.
It's like a whole new world of economic opportunity, creating jobs in everything from aerospace engineering to material science to agriculture.
Exactly. And it's not just about new jobs, it's also about expanding our knowledge of the universe and inspiring the next generation of scientists, engineers, and explorers.
Speaking of inspiration, one thing that's really stuck with me through this whole deep dive is how ambitious this whole thing is. We're talking about building a place for humans to live on another planet. It's kind of terrifying, but also super exciting.
It really shows you what humans can do. When we set our minds to something, even something as crazy as building on the moon, we find a way to make it happen.
A giant leap for humankind, for sure. But with big ambitions come big responsibilities. We talked about the ethics of settling on the moon, but I want to explore that a bit more. What are some of the biggest questions we need to ask ourselves as we start this lunar journey?
One of the most important is who gets to decide what happens on the moon. As we establish a human presence there, we need to create some kind of system for making decisions. We have to think about things like ownership, resource allocation, environmental protection, and the rights of future generations.
So it's like we need a whole new set of rules for a whole new world. What about the environmental impact? How do we make sure we're not messing up the lunar environment as we build and mine?
That's another critical question. The moon has a delicate ecosystem, and even small disturbances can have a lasting impact. We have to use sustainable practices, minimize waste, and develop tech that works with the lunar environment.
Like we're learning to be respectful space neighbors.
Exactly. And this idea goes beyond just the moon. As we explore more of space, we need to think about being responsible stewards, making sure that what we do now doesn't ruin things for future explorers.
That's a message that applies to everything we do, not just space exploration. As we deal with problems like climate change and resource scarcity here on Earth, we need to make choices that ensure a sustainable future for everyone.
It's a call to action for sure.
Well, this brings us to the end of our lunar deep dive. But the conversation doesn't have to stop here.
This is just the start of an amazing journey as we head further into space and explore the possibilities of building a sustainable future both on the moon and here on Earth.
To all our listeners, thanks for joining us on this journey. We hope you learned something new, got your imagination fired up, and maybe even felt a little bit of that lunar wonder.
Keep exploring, keep asking questions, and keep looking up at the stars.